Module 17 introduces us to sewer mining, which is the process of extracting valuable water from sewage and then treating it to very high standards. My report is about the treatment options which are viable for sewer mining. There are three removal mechanisms involved in the process of water treatment. These include physical, chemical, and biological removal. So physical removal is the mechanism employed in treatment technologies which mainly rely on separation processes such as filtration, sedimentation, and flotation. For chemical removal, coagulants and flocculants are used to increase the removal rate of pollutants. Lastly, for biological removal, this mechanism transforms pollutants into more manageable forms for separation. Currently, there are a lot of commercially available treatment technologies. These technologies treat sewage to attain the specified water quality. Pertaining to their mechanism, these technologies are categorized into three major types: biological, physical, and hybrid processes. Biological processes. These are the common treatment technologies under biological processes. First, we have SBR, or the sequencing batch reactor, which is based on an activated sludge process. So I will explain this further on the next slide. Then next, we have natural systems such as subsurface wetlands. Lastly, we have RBC, or the rotating biological contactors. In RBC, wastewater is purified using microorganism membranes. So these membranes are attached to discs. SBR, or sequencing batch reactor, is a fill and draw type of activated sludge system, and it involves four sequential steps: filling, reacting, settling, and decanting. This is the schematic diagram of the SBR process. So again, the first step is filling the reactor, and the next is the aeration or the mixing, and then settling, and then decanting of the clarified water. So to further visualize and understand this process, I have provided an animation in the next slide.
Treatment commences when sewage water from building enters the collection tank. Heavy solid particles settle to the bottom portion of the collection tank. Accumulated sewage is pumped into the SBR reactor for treatment. Aeration in the reactor further purifies the wastewater. Fine bubble aeration supplies oxygen to the microbes. Microbes, also called activated sludge, multiply and consume waste in water. In a short cleaning pulse, the discharge airlift is cleared from any sludge particles. During sedimentation phase, activated sludge settles to the bottom. A clear water zone is formed on the upper layer. Clear water is removed from the reactor through the Ecotech airlift pump. This clear water can be further filtered for reuse and recycle.
Physical processes. The common treatment technologies which involve physical processes are the sand and media filtration and the membrane filtration. So sand and media filtration involves the removal of suspended matter as well as floating and sinkable particles. For membrane filtration, it involves micro, ultra, and nano filtration and reverse osmosis. Hybrid processes combine physical, biological, and chemical processes to attain optimum results. An example of a hybrid treatment technology is the combination of biological processes and physical processes, such as the fine solid separator. Another hybrid technique is the MBR, or membrane bioreactors. Because of its advanced level of organics and suspended solids removal, MBR is considered as one of the most effective treatment techniques. Membrane bioreactors combine the conventional biological processes with membrane filtration. So, because of membrane filtration, MBR type facilities are compact in size and simple to operate. They also reduce sludge production as well as produce high-quality water.
The first step of the treatment process is the mechanical screening of incoming wastewater. The screened wastewater flows into the anoxic tank. Within the anoxic tank, a submergible mixer blends the screened wastewater with mixed liquor, returning from the MBR tank to achieve the desired level of denitrification. In the absence of dissolved oxygen, nitrate is converted into nitrogen gas in the tank. From the anoxic tank, mixed liquor flows to the anaerobic tank. The anaerobic process triggers the discharge of phosphorus by microbes in the anaerobic state reaction. From the anaerobic tank, the wastewater flows to the aerobic tank, where oxygen is injected using air blowers and a diffused aeration system. In this oxygen-rich environment, organic material and ammoniacal nitrogen are biologically oxidized into carbon dioxide, nitrate, and water. From the aerobic tank, mixed liquor flows to the MBR membrane tank for liquid-solid separation.
Another hybrid technology which utilizes biological, chemical, and physical processes is the ReAqua chemical-assisted separation process. So this was applied to deliver Sydney, Australia's first sewer mining project. As seen on the diagram, ReAqua involves both gross and fine solid separator, submerged aerated filters, a fine sand filter, and finally UV disinfection. Based on the diagram on the previous slide, here are the 4 key treatment steps used in ReAqua. First is the physical and chemical process of removing fine solids through coagulation. Next, with a submerged aerated filter, this enables the biological process of organic and nutrient removal. For the third step, another physical process is involved in removing fine solids, but this time using the sand filter. And for the last step, UV disinfection is usually coupled with chlorination. In conclusion, treatment technology should be rapid, compact, and low in capital cost in order to be effective.